Because of the weather we have here in eastern North Carolina, water can take on many different forms: rain, snow, sleet, and ice. Since ice occurs here in eastern North Carolina, I want to talk a little bit more about that phase change, going from a liquid to a solid. Now, water in general is very unique, H2O. One of the unique properties of water is that when it turns into ice, it's actually less dense than water, than liquid, so it actually floats. Think about it the next time you're standing at a pond or you're just looking at a large basin of water. What would happen if instead of freezing from the top down, it freezes from the bottom up? You have a whole bunch of ice-skating fish. So what's actually going on? Let's go ahead and take a look at it from the molecular level. I got a couple of M&Ms here and there. First things first, what is temperature? Say these molecules are each moving very, very fast, above 32 degrees. We can actually take the average speed of these molecules, average that out, and we get temperature. That's what temperature is. It's a measurement of energy. As the temperature starts to go down, these molecules start locking. And whatever gets that process started, we used energy when I slammed it down on the table. You can also use different things like pollution even can start this process. So these bonds start to form and create a solid. So how do we stop that? Well, we stop that by adding salt. And salt actually works to interrupt not only that process, that's a lot of salt. Lower your sodium intake molecules. What it does is it sets up a boundary or a fence around these molecules so they can't interlock or form those bonds. The interesting thing though about salt is that it's only so good. As the temperature goes down, the longer it takes for the ice to melt. Now in our situation, we actually used liquid water. It was super cool down below 32 degrees. And in that case, we just used energy to make it form a lot of ice. And of course, why are we talking about this? Because it comes down every day in East North Carolina, not in ice form, but in many other forms. And it's important to understand exactly what happens before we slip on the ice.